The quadratic formula is what we use when we have a quadratic equation that can't be solved easily by factoring or by taking square roots. Now, the quadratic formula is probably the most reliable way to get your answers for a quadratic equation, but it involves several steps, as you can see with the formula given right here. I'm going to read it slowly and let's talk about it. So x equals negative b plus or minus. Plus minus, that means that you're going to have two answers to many of these quadratic equations. Plus or minus the square root of b squared minus 4ac, and that whole numerator is over a denominator of 2 times a, 2a. So where are we getting a, b, and c from? Well, let's go into that process below. So we're going to solve for x. Now, if you were given this equation on a quiz or test, my first instinct would be to try to factor. It's in that quadratic style with an x squared followed by an x term followed by a constant set equal to 0. So since there's an 8 in front of the x squared, let's see if the AC method would work. If I take 8 times negative 4, I get negative 32. Are there factors of negative 32 that sum to negative 3? I don't believe so. So this is not going to be able to be factored. So what we're going to do is we're going to identify the a, b, and c in this equation. So where a, b, and c come from are where the numbers are in this equation. Ax squared plus bx plus c. So a is going to be 8. B is going to be negative 3. Remember that the quadratic form for an equation is ax squared plus bx plus c. So any negatives here do have to get reflected. And then negative 4 for c. So those are the values that I'm going to plug into this quadratic equation that I've written above. If you haven't written that down already, definitely write it down for reference. You can use it for all your assignments. When we're in school, I usually give this to you for you to use on a quiz or test. So let's begin. So to solve this equation, I'm going to say that x equals, it's negative b. So here's how I'm going to plug this in. It's negative in the formula, as you can see above, but my b value is also negative. So I'm just going to plug it in like this. The double negative is ultimately going to cancel, give me positive 3, but to just want to plug in the raw information, I want to show you that first. Plus or minus, square root, b squared. And again, when I'm plugging in, I need to use parentheses. So if I don't use parentheses there, my b is negative. There's a big difference between whether the negative 3 has parentheses around it and gets squared versus whether it doesn't. Minus 4 times a, which is 8, and times c, which is negative 4. And all of this is over 2 times 8. So again, see how the information I've plugged in here matches with the quadratic formula that I wrote above. One of the big mistakes that students often make is they put this denominator only under the radical part. This is the denominator for the entire expression here. So let's simplify. Like I said, double negative outside, so we're going to make that positive 3. Plus or minus. Negative 3 in parentheses squared is positive 9. Now I'm going to probably use a calculator for this part. So it's negative 4 times positive 8 times negative 4. Now there's two negatives, so it's going to ultimately give me a positive. Let's use our calculator for that. And we get 128. 2 times 8 in the denominator is 16. We have at least one more step to simplify here. Nine plus 128 is 137 over 16. Now we're just about done. We have one thing to check to see if we're finished. We need to look at that radical. We just got done with a couple weeks learning how to simplify radical expressions and equations. Are there any perfect square factors of square root of 137? You can go through the list. 4, 9, 16, 25. There are none. So this is actually your answer. And I want you to leave it in simplest radical form like this. You could get a decimal value and plug those decimal values in and satisfy that equation, but this series of answers, remember it's 3 plus the square root and 3 minus the square root all over the denominator of 16, is how you're going to be giving an answer. So you wouldn't be able to come up with that answer by factoring or taking a square root. So this is where the quadratic formula is the most helpful. Let's do one more example that shows one additional thing for your lesson. Same idea, quadratic equation. This one's numbers are a little smaller. We could try to factor 2 times -7, -14, but -14 doesn't have any factors that sum to 4. So I'm stuck using the quadratic formula again. A is 2, B is 4, C is -7. Plug into the formula. As I said, it's up on top of my board here, so you should have it written down in your notebook. -b, plugging in +4, so I'll just show the parentheses just to show. Every time I'm plugging something in, use those parentheses. Plus or minus, square root, it's +4 squared, minus 4 times a, which is 2, times c, which is -7. Denominator is 2 times 2. Let's simplify. So once again, got a negative times a positive times a negative, so the double negative will give me a positive. We've got 4 and 7, which gives me 28, and 28 times 2, which gives me 56. Keep going. (16 plus 56 is 72. So now 2 key steps to finish this one. Like I said in the last one, we've kind of simplified all we can, but look at that radical. Radical 72. Does that contain any perfect square factors? Well, if you did those lessons accordingly, you probably remember 72. It can be simplified into perfect square factor of 36 and 2. So in my next step here, what I'm going to do is show that. Now it's -4 plus or minus. So like I said, it's 36 and 2. That will come out as 6 root 2. All over 4. So let's look at what we have left. We have 3 terms basically. We have -4. We have plus or minus 6 root 2. And we have +4 in the denominator. What do all those have in common? They're even. So each of these terms can now be reduced by a factor of 2, since they're all even. That's their common factor. So my final answer for this problem, simplified, is -2 plus or minus. How do I reduce 6 root 2? That's now going to become 3 root 2 with a denominator of 2. So this answer, these answers, excuse me, plural, plus and minus, could be plugged in back into this equation in the top left, and that would simplify the equation. You'd get 0 equals 0 on both sides. So this is why the quadratic formula is useful.